Hello friends, in this video we're going to solve the remaining problems of this paper, Mathematical Physics PHYC3A 2024 BSc 3rd semester, Dibrugarh University. Though I have tried to complete the paper in the last part in 5, but I couldn't do that, sorry for that, and only 2 problems left. So today I'm going to complete this paper. And before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you want to follow me on Insta, this is my Insta ID, OJHALAKHYAJIT123. That's my Insta ID. You can follow me on Insta. So now let's start. So this is question number 3Z1. Okay, so here we need to check this given matrix is Hermitian or not. Okay, so what was the definition of that? What was the condition to be a Hermitian matrix? Suppose we have a square matrix A. We have a square matrix A, and its elements are represented by Aij. This means element of ith row and that column, right? So when it is called Hermitian matrix, if this element of ith row and that column is equal to the complex conjugate of z row and ith column, right? Let me explain. Now you see, just give me a second. Let me write the matrix, given matrix here. 1 2 plus 3i, then next element is 3 minus I, right? Then 2 minus 3i, then 2, we have 1 minus 2i, and we have 3 minus I, then we have 1 plus 2i, then 5i. This is the given matrix. Here you can see this is the first element. So element of first row, this is the element of first row and first column. This is 1 1, right, which is equal to 1, and complex conjugate of 1 is again 1, right? And which is you can say this is the complex conjugate of, as it is real number, its complex conjugate will be the same, right? So 1 1, if you alter the order of these two 1, you're gonna get again a and a11, right? You can say that complex conjugate of a11. So similarly, if you consider this, then you're gonna have, this is the first row second column, this is first row second column, right? So that is 2 plus 3i. If you take the complex conjugate of, it can be represented as complex conjugate of 2 minus 3i, right? That complex conjugate of 2 minus 3i is again 2 plus 3i. So here you see 2 minus 3i, this element is 2 minus 3i, this element is 2 minus 3i, right? And here you see, so that's 2 minus 3i element is in second row first column, right? So that means you can say a21, right? So now you see, just give me a second. Okay, just give me a second, right? Okay, now let me write it properly. This is 5 and 2i, okay, 3 then 2, that's fine. Okay, this is a21. Okay, so now you see these two elements satisfies this condition, aij is equal to complex conjugate of aji, right? Till now it's okay. So now let us consider this element a13, element of first row and third column. So 3 minus I, which can be written as complex conjugate of 3 plus I, but here you see 3 plus I is this is A13. If you consider the element A31, that means third row, first column, that means this one. This is 3 minus I. So this is 3 minus I, right? So if you take the complex conjugate of A31, then you're gonna get 3 plus 1 I, right? 3 plus I. So which is not equal to this one, right? So that means you can say this is not equal to A3I conjugate, right? Sorry, A31 conjugate, because conjugate of A31 is 3 plus I. So here we are getting conjugate of 3 plus I, right? So hope you have understood this. So just give me a second, let me explain it properly. Now you see, to be Hermitian, this condition should be satisfied. Aij element must be equal to complex conjugate of Aji, right? Now you see here, in this element, in this case A12, its complex this element is 2 plus 3I, and if you take A21 is which one? A21 is this one, 2 minus 3I, and if you take the complex conjugate of A21, then you get 2 plus 3I, right? Just you need to change the sign before the complex term, imaginary term, right? Before I, right? So now you see here, these two are equal. This is equal to this one, right? That means we can say this element A12 is equal to complex conjugate of A21, right? So that means this condition is satisfied. Now you see in this term, here you can see, in case of A13, right? In case of A13, we have got A13 is 3 minus 1, right? And A31 is also 3 minus 1. If you take the complex conjugate of A31, you're gonna have 3 1 plus I, okay? A13 is 3 minus I, and A31 is also 3 minus I. So if you take the complex conjugate of 3 minus I, then you're gonna have 3 plus I. So these two are not equal, right? So here you see A13 is not equal to complex conjugate of A31, okay? So since A1ij is not equal to Aji for all I and j, okay? So therefore the given matrix is not Hermitian. Right? So hope you have understood this. So this was 3gi, okay? This one is solved. Now let me solve 3g2, which is the last problem, okay? So first let me clean this. So now we need to find the inverse of the following matrix, okay? So how to find the inverse matrix? First we need to find the determinant of this matrix, right? And then we need to find the adjoint matrix, okay? Then inverse matrix of A will be given by this inverse matrix will be given by 1 by determinant of A, then adjoint of A, right? So that's how we used to find. First let me find the determinant of this matrix A. So this is the matrix A. Let me write the matrix. So 3 minus 3 4, 3 minus 3 4, just give me a second, and 2 minus 3 4, the next row is 0 minus 1 plus 1, that is the matrix. So let me find the determinant of this matrix. Hope you know how to find the determinant of this matrix. First let us take this element 3, then into, so if we consider this element, then we have to ignore this column and row as well. then we have to take these 4 elements. Okay, from this side multiply 3 into minus 1, that is minus 3, then minus 1 into 4, minus 4, so minus it's gonna be plus, right? So that is plus 4. So next, this was positive, now alternatively positive and negative. Now here you see, for the next, here we have minus 3. Now ignore this column and this row. Then what happened? Now you see, let me clean this first. So when you take this element, then ignore this column and this row. Now let us take these elements, okay, for calculation. Then multiply from this side 2 into 1, so that's gonna be 2. Then 0 into 4, that's gonna be 0, minus 0. That's what we're gonna have, right? So hope you have understood this. Now you see, just give me a second. So now let me show you something, just wait. Now you see, here we have taken positive, here we have taken negative, then again we should take positive, right? So now you see, here let us take this element 4 into, then when you take this element, ignore this column and its corresponding row as well. Then 2 into minus 1, that's minus 2, minus 0 into minus 3, that is 0, right? So hope you have understood this. So hope you know this, how to find this determinant of a matrix. 3 into, this is plus 1, then minus plus, 3 into 2, then 4 into minus 2, right? So that's going to be 3, 6, then minus 8, that's going to be equal to 1. So we have got value of this determinant A is equal to 1, right? So hope you have understood this. Now let me clean these things, just give me a second. Okay, that's what we have got, right? So now you see, so I'm gonna clean this part, okay, plus here you see, just, so what we have got determinant A is equal to 1, okay? But you have to note all the steps that we have done, right? You have to write all these steps, okay? Just to have enough space, let me clean this, okay? So let me write the final result only, that is equal to 1. So adjoint determinant of A we have got 1. So now let me find the adjoint matrix. Before that I need to find the matrix of cofactors, matrix of cofactors, okay? So how to find that matrix of cofactors? First, how to find a cofactor of this element? So again, minus 3 into 1, okay. First we're going to take positive, minus 3 into 1 is minus 3, then minus 1 into 4, that's going to be minus 4, so minus 4, so minus is become plus 4, okay. Then for the next term minus 3, again here we need to take, for this term next should be negative, okay, alternatively positive and negative. For this one, what we need to do, we need to multiply this one and this one, okay? That is 2 1s are 2, minus 0 into 4, that is 0, right? Hope you have understood this. These two are separate element, don't think that this is minus this one, okay? So we are not subtracting this one from that, these two are separate elements, right? Hope you have understood this. So now let me clean this first, okay, just give me a second, okay. Next one, again we have to take positive. For this element 4, we need to multiply this 2 into minus 1, that is minus 2, minus 0 into 3, that's going to be again 0, right? That's going to be again 0, right? So that's what we have got. So first row is completed now let's take the next row for this element. So what we need to do, we need to multiply this one with this, right? We need to ignore this row again, right? And this column as well, again same process. Okay, so hope you have understood this. So here it was positive, this is negative, positive. Now again we're gonna take negative, alternatively positive and negative. Then -3 plus 1, that's gonna be -3, right? Then minus -1 -4, that is -4. Sorry, -1 plus 4, that is -4. As we have minus sign here, so we're gonna write +4, right? Hope you have understood this. So now just give me a second. As we have taken here negative, now let me take positive again. Now cofactor of this term -3, again ignore this column and this row. Then 3 into 1, right? 3 into 1, that's gonna be 3, minus 0 into 4, that's gonna be 0, right? Then as we have taken positive here, now next term should be taken as negative. Okay, so now for this element, cofactor of this element, again ignore this row and this column. Then now let us multiply 3 into -1, that's gonna be -3, right? -3, then minus, so for this one 3 into -1, that is -3, and 0 into -3, again 0, right? That's what we have got. So now next row, this is 0. For 0, again ignore this row and column, right? So then here we have taken negative, now we're gonna take positive, right? Just give me a second. Positive. So now -3 into +4, that's gonna be -12, right? That's gonna be -12. Then you see -3 plus 4, again -12. As we have minus sign already there, so -12 and minus, that's gonna be +12. Now as we have taken here positive, now next term should be taken as negative. So this is the cofactor of 0. Now cofactor of -1, this, again ignore this row and this column. 3 ones are, sorry, not this one, 3 into 4, again 12, right? 12. Then 2 into 4, 8, right? Then again take positive. For the cofactor of the last element, this, ignore this part. Okay, so now 3 into -3, that's gonna be -9, minus 2 into 3, that's -6, so -6, that's gonna be +6, right? +6, right? That's what we have got. So now let me find. So 1, then this is gonna be -2, then this is also -2, right? Now here we're gonna have +1, then here we have minus, so it's gonna be -1, then 3, then -3, that's gonna be +3, and the last row, that's gonna be here you see +12 -12, 0, then -4 plus 4, just give me a second. Okay, sorry, here 12 minus 4 is 12 minus 8 is 4, we have minus here, so it's gonna be -4. Then -9 plus 6, that's gonna be -3. That's what we have got. So how to find the adjoint matrix? Okay, so now let me clean this. Okay, you need to write this step, okay, but to have enough space, let me clean this part. Okay, let me write the final matrix only. So this is what we have got, right? So now you see, now how to find the adjoint matrix, adjoint of A. So take the transpose of this matrix. Okay, how to take the transpose? Just make write this column as row 1 -1 0, then next column as next row -2 3 -4, then again third column as third row -2 3 -3. So that is the adjoint matrix that we need to find, right? Hope you have understood this. So therefore the inverse matrix of this given matrix so I am using the letter A here, so that's why A inverse, so you can write this one, just A inverse equal to 1 by determinant of A and adjoint A, so that's going to be 1 by 1, and let me take this adjoint of this A. Okay, so this is going to be equal to, simply just give me a second. Okay, so therefore the result will be, final result will be this. Here you see, sorry, so this will be the final result, right? They are supposed to be -3. Okay, so hope you have understood this. So this paper is completed now, so hope you have understood this, and if you like this video, please do share with your friends, inspire me to create new contents for you. And if you need different courses of mathematical physics, you can visit my channel. You can check the playlist for Laplace transformation and Fourier transformation, differential equations, and for any other courses like quantum mechanics and relative special theory of relativity. For different courses, there are different courses available in my channel, so you can check those. Okay, so see you in the next video. Bye bye.